Hi guys, here we're looking at our theorem 5. So theorem 5 says opposite angles of a cyclic quadrilateral add up to 180 degrees. So what they mean here, if we have A, we have A, B, C, D, basically they saying that if you add angle D and angle B, you should get 180, and if you add angle C on A with C, you should get 180 as well. So these two opposite side must give you 180, but this is only possible if all your angle are touching the cycle. Like you see, this A here touches the cycle here, it touches the cycle here, it touches the cycle here, it touches the cycle here. So this means in a situation, maybe if you have something like this and something like that, and then you can say when you add these two angles they give you 180, and when you add these two angles they give you 180, but all your angles must be touching the circle. Okay, so this does not hold. Okay, let's look at it quickly to look at the proof for this. Let's say we're trying to prove that if you add B plus D can give us 180 degrees. Maybe we're trying to prove that. So what can we do here? We need to do some construction. So construct a line AC, because we want to prove that B plus D is equal to 180. So this is us constructing a line. This is our line that we constructed here. So you see, between AC we can say our O is here, our center, meaning the origin is here. So this is our O. We have constructed a line AC. So if you're looking at the line AC, what can we do here? We can use theorem 2, I guess. So theorem 2 says that this angle here is twice this angle here. So it says this angle here is twice this angle here. So what does this mean? It means we can look at this as we can have O2, O1 and O2, and basically we can say that this angle here is twice that. So we can say that O1 is equal to O1 is equal to 2B using theorem number 2. Using the theorem number 2, so we can say because of the reasoning, it's an angle at the center. Of a side. So we can say it's an angle at the center of a side. So that can be our reasoning. And the other thing, if you're looking now, suppose okay, so that was if we're looking at our center here. So we look at O, O2 and O1. So here we're looking at this and this, and we can look at the opposite of it, meaning that we'll be looking at this angle here and this angle here. So what can we say there? We can say O2 is equal to 2, O2 is equal to 2, O2 is equal to 2D. So the reasoning would be the same. We have the same reasoning, right? So let's look at our O1 plus O2. O1 plus O2 will be 360 degrees. And what is the reason? So this is an angles around a point. Angles around a point, because we're looking at this one O here, so they make a 160 degrees. So what does this mean? We know what is our O1. Our O1 is 2p, so we have 2p plus our O2 is 2d plus 2d is equal to 360 is equal to 260. Let's undo that. So it's simple, equal to 360. So you can divide by 2, you will get P plus D is equal to 180 degrees. Hence you have proved that if you add these opposite angles, you're getting 180. So this is how you can prove it. Okay, or else there can be some other way which I think is somehow simple or easier if you're looking at proving this. So you don't need to do both, but you can do one. You can just do one method, so you don't have to do both methods. So it's done, but this is another method or another option of how you can do it. So you're still constructing this line here. You're still constructing a line AC. So what can we do here? We can also use Theorem 4, because with Theorem 4 we already know that with Theorem 4 we know that our P is 90 degrees. So we know that angle P is 90 degrees. And what would be the reason? It's an angle subtended. It's an angle subtended by diameter of a circle is equal to 90 degrees, and hence we know that D is also equal to 90 degrees. For the same reasoning, hence B plus D is equal to 90 plus 90, which is equal to 90 degrees. So I think this one is simple, but either way you can use any, because you see this is 90 degrees and this is 90 degrees. So when you add them, they give you an 80. Straightforward and simple. So you can choose which one you want to use. You can use the first one, write it, or you can use this one. And thank you so much for watching. So that is for this Theorem 5 and the proof of it.